Good evening, everyone. Can everyone hear me? Is everyone in? I can see some vacant spaces, so should I start? Cool. So I'll quickly kickstart today's session. Today's session is more of a mixture of machine learning, how you can use Python to create web applications. So if you are someone who is a developer, who is either a front-end developer or a back-end developer, if you are someone who wants to, say, basically create ML-powered web applications, which is where TensorFlow Hub and the solution today that I show you will come into picture. I hear a lot of echo. Is it just me or is everyone hearing echo? All good, right? Okay. So today's session that I have in mind is building ML-powered applications using TensorFlow Hub. What is TensorFlow? What is TensorFlow Hub? How do you intend to create web applications? What is the library that I'll be using is all that I'll discuss in today's session. Okay. So just to give you a brief background about what I do in my day-to-day life, I work as a senior data scientist at Colgate-Palmolive. Everyone brushes their teeth, so I'm assuming this company is a known company for everyone. So at Colgate-Palmolive, what I do is I create ML-powered solutions to optimize our overall return on ad spends on Amazon. So there are different places where we make investments. How do we optimize the money that we are spending to generate maximum returns is where machine learning comes into picture. It's a pure ML-driven business-powered role. So I create ML solutions that kind of drive business forward. So that is what I do in my day-to-day life. I also happen to run a YouTube channel with the aim of teaching machine learning, data science, Python, and whatever I learn in my job is what I replicate in my channel. So feel free to check it out. If you have your, say, cameras on, you can scan this QR. You will directly be redirected to my channel. There are some things which I'll kind of skip because I'll kind of quickly skip. I'm a Google developer expert in ML. I'm a GitHub Star and XYZ things. I'll straight come to the, say, the presentation that I have in mind. Before I start the presentation, the one thing that I want to share across with all of you is, before you start creating a solution, always think of ways in which the solution has already been created. So let me start off by the quote, don't reinvent the wheel, just realign it. When I say don't reinvent the wheel, there are situations wherein you will feel the need to reinvent the wheel. Just look around. If there is a solution that already exists, take that solution, remodify it, and then utilize it, which is where you can kind of create some amazing applications. A simple web-based application that I can give you is, say, for example, if you are a startup founder who is business-driven, who knows a lot about business, if you are someone who has very limited knowledge of, say, web technologies, rather than creating an entire new library or, say, rather than learning HTML, JavaScript altogether from scratch, you can use, say, WordPress and create solutions. This is for someone who is a business user, right? For developers, you can kind of start from scratch. There are places wherein you can use libraries as well. So with this basic idea in mind, I'll start with today's conversation. Machine learning is evolving every day. When I say every day, it's literally like a year back when OpenAI had released GPT-3. This year, 3.5 has come out very silently. With 3.5, they have trained a new agent wherein you can now chat with ChatGPT, and the results, I'm pretty sure if you are using any social media, everyone's talking about ChatGPT, right? So with the amount of research that's happening in ML, it's very difficult to keep track of everything. Plus, if you want to utilize solutions which are state-of-the-art, there are few challenges that are there that every, say, data scientist goes through. For example, if you happen to find a model that is hosted on GitHub, there are multiple questions that I would have before I start utilizing it, right? The first thing is, how do I start utilizing it? A lot of GitHub, say, repositories will lack proper README files, wherein how do you run the entire repository, how do you clone it, how do you have the environment variable set up. All of these are questions that you would have before you start using the model. Is it safe to use? If I use a model, would it damage my system, or would it basically corrupt my system? There are many things that would come into picture, because you essentially don't know if it's not from a trusted source. Can you trust the solution that you're about to use from a publicly hosted GitHub repository? The other thing is, has it been trained fairly? When I say fairly, there's been a lot of debate with respect to machine learning producing colors. So the skin colors that a lot of cameras produce on our cell phones are not accurate to our Indian skin tone, right? This is a problem that Google is trying to solve. So the Pixel series that came out, the new camera application in Google Pixel, they say that it is true tone based, something of that sort, right? So they've trained models for different people from different continents so that they're able to better reproduce the colors for different skin tones, okay? Which is where, as the model that you're trying to use, has it been trained fairly or not, is a question that everyone thinks of answering before utilizing a solution. And is this the latest version? Today I'm using ChatGPT 2.1, for example. Maybe a month later it would be 2.2, 2.3. Rather than using something that is, say, old, am I using the latest version, is a question that every developer has in mind, right? So keeping everything in mind, what is that one place or one solution that you can definitely rely to create a solution, right, which is ML powered, which is where TensorFlow and TensorFlow Hub come into picture. So I'll give you a small introduction about TensorFlow. For people who are new to the entire machine learning ecosystem, TensorFlow is basically an open source library, open sourced by Google again, wherein you can create neural networks, deep neural networks from scratch. The advantage of using TensorFlow is you can prepare data using their custom functions which are available. So if you have, say, multiple data points that you want to iterate through, there are different iterators that are available that you can easily use through TensorFlow. You can build ML models, so you can train ML models from scratch. If you have an existing case wherein you have a pre-built model, you can utilize that pre-built model, retrain it again for your use case, and then again come up with a solution. You can deploy models. One of the advantages that TensorFlow seemingly has over PyTorch is the ability to deploy models in different environments. So that is one use case where TensorFlow kind of wins over PyTorch. And if you want to create an entire MLOps or a proper CI/CD pipeline, wherein you want to keep retraining the model again and again, keep the deployment loop running, which is where you can kind of integrate TensorFlow with an MLOps pipeline. So this is where TensorFlow ecosystem comes into picture. And the solution that I'm going to talk about today is TensorFlow Hub. Now TensorFlow Hub is like the GitHub of all the open source models that you can rely and trust upon, right? So if you have a use case wherein if you're creating a chatbot, or if you are creating a sentiment analysis based solution, or if you're creating an image classification based solution, if there is one place where you want to fall back upon, if you want to rely upon the different problems that I've mentioned in the previous slides, which is, if you don't want these problems to occur in your solution, then there is one-stop solution that you can readily rely upon, which is TensorFlow Hub, okay? Everyone with me? Yes? Perfect. So when I say TensorFlow Hub, there are different categories of pre-trained models which are available. You will have models with respect to text. You will have models with respect to images. You will have models with respect to video. And you will have models with respect to audio as well. So there are broad categories of ML models that are readily available, be it from images, text, video to, say, audio. When I say audio, think of it as classifying multiple speakers in an audio file. So for example, if there are two people speaking, right, you want to identify which part of the speech is spoken by speaker 1, which part of speech is spoken by speaker 2. If you want to differentiate different speakers, which is where you have pre-trained models that are already available on TensorFlow Hub, okay? So I'll quickly take you through the different, say, problems that you can solve using TensorFlow Hub in each of the categories. First is text. If you have some set of reviews on Amazon, if you want to classify them into positive or negative, you will have sentiment analysis that comes into picture. All of that falls into the top category, which is classification. Embedding generation. So for, how many of you know BERT? Google's BERT model that is powering currently the Google search engine. Google's BERT is basically representing every keyword that you can think of in form of a token, in form of a vector, which is basically nothing else but an embedding. I'm kind of oversimplifying things right now, but embedding basically is a high dimensional representation of a word that will have some amount of context within it, right? So if you have two words like king and queen, are they related or are they unrelated? King and apple, are they related, unrelated? King and queen, are they related, unrelated? Perfect. So all of this relationships, all of this context that you think of is essentially where embeddings come into picture. So what Google has developed is something called as BERT, and they've kind of open sourced it, which everyone is kind of utilizing today. If you want your words to be context aware, which is where your embeddings come into picture, okay? Now, I'll give you one more simple example. An apple a day keeps a doctor away. I have an Apple iPhone 14 Pro Max, okay? Two sentences. Apple, the word is the same. If I feed this to a computer, if my embeddings are not context aware, then the representation of Apple in both the cases would be the same, okay? But if you have context aware embeddings, the machine would understand the first apple is a fruit, second apple is the Apple organization, okay? Which is where context comes into picture, okay? Similarly, when you think of image, you have image classification. Now, if you have an image of a dog, which is what I'll kind of come to as well in the next set of slides. If you have an image of a dog, and if you have different breeds of dogs, can you classify different breeds of dogs using, say, your cell phone? So if I have a use case wherein if I point a camera to, say, any object, can I classify that object, which is where image classification comes into picture. Object detection, if you want to detect where the object or class is in the image that you see, is where object detection comes in. Semantic segmentation, how many of you use portrait mode in your camera? All of you? That's a simple example of semantic segmentation, okay? Behind the scene, what is happening is, you have an image, the image of, say, a background and a foreground. Using semantic segmentation, what we are able to do is, we are able to segment the foreground image and the background image, and we are able to blur the background and keep the foreground in focus. That's a clear case of semantic segmentation, okay? Then we have some video-based classification models that are readily available on TensorFlow Hub. So for example, if you have, say, if in a video you want to detect what object there are, if in a CCTV you want to detect whether a particular person exists in that video or not, you can train models accordingly as well. In audio, I've already given you an example, which is detecting different, speakers in a audio conversation. Where is this useful? Say, for example, if you have a CRM company, companies wherein you take complaints, customer complaints, you want to identify what part of that audio file is basically spoken by the customer and what part of the audio file is spoken by the actual customer care executive, right? You want to differentiate both the speakers. You want to identify who is doing a better job. So if I have 10,000 customer agents who are serving customer request, I want to identify who is my top performing customer agent. I can divide all the audio files into who spoke which part of the in which part of the file, and then figure out how the efficiency of that particular speaker is, right? So there are tons of things that you can do with audio as well, which is where the entire CRM agency is now seeing a lot of changes in the approach of how they handle customer queries, right? So these are some of the readily available models that exist on TensorFlow Hub currently. All you have to do is write very few lines of Python code. How many of you are, say, decent with Python? If you've ever worked with Python before, like, A equal to 5, B equal to 2. So basic, right? So if you have some basic knowledge of Python wherein you can write a for loop, if statement and all of that, you can easily utilize TensorFlow Hub and create solutions using this, okay? Why is TensorFlow Hub so popular and why is it gaining so much of popularity? Given the ecosystem of TensorFlow that we are in, if you are using a TensorFlow Hub based model, you can create an entire MLOps based pipeline using the TensorFlow extended suite, wherein you can create an entire data pipeline right from data collection to data manipulation to ML model building to model retraining to model deployment. All of this is something that you can kind of utilize through TensorFlow extended, okay? Is this part clear? The second piece is for all the web developers in the house, if you want to create an ML solution and deploy it on your browser, TensorFlow.js is something that you should definitely explore. Create a model in your normal TensorFlow ecosystem, convert that model from TensorFlow to TensorFlow.js, and use your web browser to make an inference. Again, it will all depend on how big your model is, and the output may take a long time, or it may be quicker depending on how you've trained the model and how big your model is, right? The other thing is TensorFlow Lite. So for people who create Android applications, if at all you want to create an Android-powered ML solution, then TensorFlow Lite is something that you should definitely explore. Create a model again in TensorFlow, convert that to TensorFlow Lite. The size of a 1 GB model can be reduced to a 10 MB file as well if you start using TensorFlow Lite, okay? TensorFlow Lite can then sit in your mobile Android application, and then you can create solutions around it, right? How many of you know Arduino, Raspberry Pi? Everyone, awesome. So the same TensorFlow Lite model which you intend to deploy on Android devices can also sit into Arduino, Coral, or Mbed devices that can make an inference, right? So if you create maybe an object detection, so if you have a camera, if you have a CCTV, and if you don't have the money to create your own server, you can plug in a Raspberry Pi, keep the feed running in, check if there is an unwanted person who's entering your region that you're scanning through your CCTV, and create an alert through Raspberry Pi or an Arduino board. So there are tons of things that you can do with an ML powered model that would be deployed on a Raspberry Pi or an Arduino device, okay? Now how to use, right? I've spoken about the advantages and all the good things about TensorFlow Hub. Now I'll show you how to utilize TensorFlow Hub and how with very limited lines of code you can create an entire running web application that will help you classify things with few lines of code in Python, okay? Can anyone, how many of you like dogs here? Can anyone tell me the breed of this particular dog? Everyone was very enthusiastic. As soon as I ask you the breed, everyone's kept their hands down. Anyone? Poodle. There's a full name for this. Poodle is the last part of the breed name. Okay, I'll let ML give you the answer for this as well, okay? So if this is what you want to classify, if you have say a cell phone in your hand, if you point the cell phone directly to this dog, and if you want the model to tell you which particular breed of dog it is, all you have to do is basically use TensorFlow Hub in a smart manner, and you will have the solution in front of you, okay? Start off with some simple lines of code, TensorFlow STF, TensorFlow Hub. Here, for every model that you utilize from TensorFlow Hub, there is a set of documentation that is given. I mentioned the advantage of using TensorFlow Hub, that is you have a readily available documentation in place, wherein how do you utilize the model, how do you retrain the model if at all you want to retrain it. All of this is something that is readily available. So what I've picked up right now is a pre-trained model. I'll kind of tell you the name of the pre-trained model as well. But all you have to do is pick that pre-trained model, go through the documentation section of the TensorFlow Hub model, and you will have a set of, instructions in terms of how you have to basically go about creating the solution for it, okay? So here what I've done is, this particular model is capable enough of batch-wise prediction, okay? So it can take in, say, 32 images at once, and it can give you 32 outputs at once, okay? So this is the capability that this model has been trained for. So what I'm doing is I create a NumPy array of images, which will have multiple images of multiple dogs, okay? This is the main line of how you have to import the TensorFlow Hub model. Hub.keras layer, you pass in the URL of that particular model. Again, all of this is given in the documentation of that particular model that you want to utilize. And you create a model instance called as classify. And you pass in all the set of batch images. Here is where I've written some pseudo code. This is not the actual Python code. I wanted to give you how the entire process is. So I call the classify, say, model. I pass in the set of images. That is a batch of images that I want to classify. I'll have a set of probabilities. I will extract the maximum probabilities from every axis so that I can pick out the topmost class that is there in every array that is there, okay? And I finally print all the class IDs, okay? So when I do this for this particular dog breed, it is basically toy poodle, okay? So poodle was correct, but there was some part missing which was toy, so it's a toy poodle, okay? Now here what we have done is we've used an existing model that had been trained for 1,000 unique objects, okay? I don't want so many objects, right? I may have a use case wherein I want only 4 objects to be classified, right? Say for example, if I'm running a KYC document classifier, I want to classify whether a document is Aadhaar card, PAN card, passport, or driving license, right? So in that case, can I use an existing model and suit it for my particular use case? Yes, no, any thoughts? So again, I repeat, there is a model that already exists, which has been trained for 1,000 classes, different classes, dogs, cats, cars, tractors, etc., etc. I wanted to suit my use case, wherein I'm able to classify, say, PAN card, Aadhaar card, passport. Can I do that? So I heard yes and no. I'll say yes, and I'll tell you, you can change the model a bit, and which is where I'll come to the next topic, which is transfer learning. Transfer learning is smartly, if you go back to the initial code that I started off from, what was the code? I forgot. Don't reinvent the wheel, just. So that is what transfer learning is. Rather than building an entire model from scratch, don't create an entire model from scratch, because say deep learning models are really large. You will have 30, 35, 40 layers and all of that, right? Training such a big model is not a joke, right? You have to take care of a lot of things, right? You shouldn't have a model wherein your gradients start drying at the end. Training is stopped as well. So rather than creating something from scratch, use something that already exists and modify it for your particular use case, okay? Now what is transfer learning? When I have a sentiment analysis task, okay? Everyone is aware of sentiment analysis. I am happy. What sentiment is it? Positive. I am sad. What sentiment is it? I am kind of happy but not also sad. What sentiment is it? Neutral. Okay? So what I've done right now is I've given you a use case wherein if I have a model, a sentiment analysis model, which can classify sentiments based on text into either positive or negative sentiment, I want to modify that entire model so that it is able to detect, say, 2 new classes: positive, neutral, negative, somewhat positive, okay? I'm keeping an arbitrary class here which is called as somewhat positive. Now if I have to create a solution for this, what I do is I take the existing model as it is. The final layer is not something that I'm interested in, right? I don't want 2 outputs. I want 4 outputs. So I keep the entire network as it is because it is doing a good job. It is say 95, 96% accurate. I want something that to classify 2 new classes. That is 4 new categories, positive, negative, neutral, somewhat positive, okay? So what I do is I chop off the network. I'm interested in only this part of the network. I take this part of the network. I add or I create a new network with random weights, okay? And there are 4 classes that I've say designed here. Positive, negative, neutral, somewhat positive, okay? What I will do now is I'll retrain the model, not the entire model, but the final set of weights. So that I'm able to adapt whatever the model has learned initially for my final set of weights which are there, so that I'm able to classify a review into positive, negative, neutral, or somewhat neutral, or somewhat positive, right? So this is the use case that I'm trying to tackle using transfer learning, okay? Again, just to repeat, I have a model already with me. I chop off the end layer, I add a new layer, I retrain the final layer, and I get what I want, which is a classifier that is able to classify review into 4 unique categories, okay? This is the process. Whatever I've spoken is what I've condensed into this particular slide. Start, obtain a pre-trained model, create a base model, freeze layers. So the initial part that I'm not touching is what is called as freezing the layers. Train the new layer on the new data set that is created. Improve the model via fine tuning, and then end with your final model that is ready, okay? All whatever I've spoken, if you are doing it for an image related task, this is how, so for the example that I gave you, if you have 1,000 classes, and if you want to condense it to say only 3 classes, this is how you would go about the entire activity. This is your entire network. You chop off this region, which was able to classify it for 1,000 classes. Remove this, add a new layer, which is able to classify only 3 classes. Retrain the final layer, and that is where you have your transfer learning based solution, okay? Now, what I'll do is, I'll give you an example live in terms of how this happens. I'll use an existing model, I'll retrain it, and I'll show you how it can be done using, again, TensorFlow Hub, how retraining can be done quickly, and how you can create, finally, a web application with, can you guess how many lines of code? Once you have the model ready, can you guess how many lines of Python code are required to create a web application? Less than 10 lines. Okay, I'll show you the magic as well, okay? So this is a data set. This is readily available on TensorFlow's site. It's basically a flower data set. You have different sets of flowers here. You have sunflowers, you have daisy, you have roses, you have tulips, and the others that are there, right? Just to give you some more background, this is the overall distribution, somewhat equal. You will have a maximum of dandelion, which has around 900 samples. But other than that, almost every class has around 700 samples, right? This is a classifier that I want to build using TensorFlow Hub. There is no exact model that already exists on Hub right now for this particular use case, okay? What I'll do is, I'm using TensorFlow Hub and transfer learning to create a new model, which is where I start off with TensorFlow as TF, TensorFlow Hub as Hub, and here is where I create a variable called as data_root, which is able to create a pre-processing pipeline for all the images that exist, right? So if you have a data set which has 5 classes, I create 5 folders in that. I want to read 5 folder images into say a repository or into a variable that is able to pre-process images, augment images, and all of that as well. So that is where the entire utility of TensorFlow's pre-existing functions come into picture. I define the image size. All of this is something that I'm not doing because I like this particular image size. All of this is again predefined by the model that already exists on TF Hub. So the 224 cross 224 that exists is something that is that is the dimension that the model accepts by default. That is where the model has been trained on. That is the size of that particular images that it accepts, right? What I do next is I carry out some pre-processing after I've created the above variable. I say that this is where my images exist. Validation data set is where I want to validate my model output during training itself, which is where I have a validation data set. I say the subset of validation data set would be training itself. I define a seed number. Can anyone tell me why is seed important? Any guy who's kind of well versed with Python? Yeah. Perfect. Perfect. So every time if I give you a solution, and if you want to create the same exact solution at your end, you have to pick the same set of numbers for training, same set of samples for training, same set of samples for validation, which is where your seed number comes in becomes very important. If your seeds are the same, you can replicate the entire process that I'm following in my machine into your machine as well, right? So just to give you an example again, if you have 10,000 samples, okay? If you want to train a model using 10,000 samples, if you have not set the seed, the model will pick random, say 10,000 samples for training from my data set and 10,000 random from your data set. So the numbers would vary. If in order to have that coherent output in across all your systems, seed value comes into picture, okay? And finally, I have a batch size. Can anyone tell me why batch size is important? Perfect. If I have 1 million images, bring in any GPU. It cannot process all the images at once. Like there would be GPUs, I shouldn't say this, but if you have to do it on normal GPUs that are available to you free of cost on Google Colab, then you cannot process all the images at once, which is where training batch-wise becomes, say, important, right? So batch-wise is if you have 10,000 samples, I want to train a model, I'll do it by placing, say, 20, 30 samples at once. Keep training the model by showing model 20, 30 samples at one instance, okay? Now yeah. In the long run, if you are able to train it for longer number of epochs, then no. Because you will show one input multiple times to the same model if you run it for multiple epochs. So ideally, no. Best way would have been if I can show all the images at once, but hardware-wise it is not possible. Now here is where I download a different model this time, which is the feature extractor model, okay? Now just to give you context, if I go back a bit here, if I have a face recognition task, okay? And if this is the network that is generated, right? What will happen in the initial layers is it will extract features from the images that it sees, right? For an image classification task, the features that it will recognize are eyes, nose, eyebrows, forehead, and so on and so forth, right? So when I say I want to retrain a model using the features that already exist that have been generated from a pre-trained model, what I'm essentially doing is for, say, a flower data set, what it would have done is the features would have been petals, leaves, what do you call that, branch, stem, right? My biology is very bad, so yeah, stem, leaves, etc., right? The small objects that help you identify a bigger object is what features are, okay? So what I do in case of our example, which is flower classification into 5 classes, I call the feature extractor model, which will only have features outputted at the end, okay? So the output will only contain features, that is the small parts of your flowers. What I do at the end is where I create a feature classification layer, wherein I extract the feature extractor, I pass in the input shape, and I say trainable equal to false. Can anyone tell me why is trainable set to false? If you've listened through the entire conversation, you would have an answer for this. Yeah. Perfect. We only want to update the last layer. I don't want to change the features. It's able to extract flower petals. It's able to extract the stem. I don't want to update anything beyond that. I don't want to update anything before that. I want to update everything beyond that, which is where I say trainable equal to false. I say number of classes equal to the length of number of classes, which in our case would be 4, right? In our case, how many classes are there? 4? 3? 5. I'm just checking if everyone's awake or not. So the total number of classes that we have are 5. I create a model by defining the sequential layer. I pass in the feature extractor layer, and I call the dense layer, which would be something like the connections to the 5 layers that are there. That is my dense layer. And I call the model.summary function, okay? When I do that, here is the summary of the model, okay? If you look very closely, all whatever I've spoken will make a lot of sense here. I say the first layer, which is the initial layer, the feature extractor layer, it has close to 22 lakh 57,000 trainable parameters, right? The final layer has 6,405 parameters, right? If you read this particular line, the total number of non-trainable parameters are 22 lakh 57,000. That means in this particular model, I don't want to train the feature extractor layer. I'm only training the final layer that I've generated. This is how you read the model.summary properly if you are doing a transfer learning task, okay? What I'm doing is I'm going a bit in depth so that you are able to get as much as possible from the entire activity, right? Once you do that, you have your normal process. You compile the model, you fit your data. When you say fit, it simply means you are showing images to your model or your machine so that it is able to understand patterns and it is able to update the weights in the final layer, okay? All of this is through backpropagation. So this is the final output that I generate, okay? The loss keeps going down, and with every iteration, the accuracy is increasing. Just to check if everyone's awake, and for people who have done some amount of courses in deep learning, are the two charts correctly aligned? Is it reversed or is it correct? When you keep training a model, does your loss go down or does your loss increase? When you keep training a deep learning model, does your accuracy increase or does your accuracy decrease with time? So is this correct or is this wrong? I couldn't hear correct properly or I couldn't hear incorrect properly. So are the two say charts correctly aligned? So that is accuracy which is hidden. The left one is loss. That is what I've written. Is this correct? Anyone with a no? Yes? This is after T. Come on guys. Yes? No? Perfect. Yes. This is correct. I just wanted to check if everyone's awake. So I keep doing this. Okay. Once I train the model and once I show some unseen data to this particular model, I have close to 87% accuracy. And a way to measure how good your model is through say this particular matrix called as confusion matrix. The diagonal elements correspond to the right predictions. The non-diagonal elements corresponds to where mispredictions are happening. So this is what you have. So if you see here, for daisy, 92% of daisy flowers are classified as daisy flowers, right? For 8% cases, daisy flowers are classified as dandelion flowers. Okay, that's how you read this. Okay. Now I come to the final part, which is where, if you remember, somewhere in between I told you, can you create a web application using an ML powered solution, which is what the talk title is. Here is all that code that you require. Once you have trained the model, or if you're using a pre-trained model, once you have the model with you in a variable, this is all that you require in order to create a web application. Import Gradio as GR, One library is all you require. You create a function, define predict underscore image, wherein you pass the image. Input image equal to input image dot reshape minus 1, 224, 224, 3. The reason why I'm doing this is because I want to make a prediction of only one image, which is where -1 comes into picture. 224, 224, that is the size that was predefined by the model. 3, because there are 3 layers in an image, RGB, okay? Prediction is equal to model dot predict input image. So here is where the model would make a prediction with respect to the top 1000 classes, right? Top 1000 classes? 5 classes, perfect. So once that prediction comes out, you will have a set of probabilities that I can output. Here in this case, all the other probabilities would be 0. I wanted to show you that even that is possible, wherein you predict the output probabilities and you can then return the output probabilities in this format, which is given in the return statement. Now, how do you create the interface, right? This is the function that makes a prediction. How do you create an interface? You start off with image is equal to gr.input.image. So if you want to input an image, you have an interface for an image. If you want to input an audio file, you have an input interface for an audio file as well, okay? Label is equal to the output labels that are there in your output prediction. So which is gr.outputs.label, number of top classes equal to 5. We have 5 classes. So that is what I want to display as well. And finally, for creating an actual web interface, you require just essentially one line of code, which is gr.interface. You pass in the function which will make a prediction through your model. You pass in the input. You pass in the output. Interpretation equal to default. We'll skip that for now. And dot launch, debug equal to true. If you want to debug if your output is not up to what you expect, and if there are some errors that are creeping in, and if you want to understand those errors as well, which is where debug equal to true is what you have to set. Can anyone classify this for me? Which flower is this? Out of the 5 classes, I'm giving you a hint. This is not as complex as the dog example that I gave you. You have 5 classes, right? Daisy, dandelion, sunflower, there was rose as well, and there was one more. Which is the tulip, tulip. Is this tulip? Which flower is this? Daisy? Rose? Since there is a lot of confusion, I'll let ML decide which flower this is. Okay? The interface code that I showed you will give you this particular interface. 3 lines of code, 4 lines of code, but this is the interface. Drag image here or click to upload, and there is where your output would appear. I upload the image, and the model says it's a rose, so I'll take it for the face value again, that it's a rose. So here, what I've done or what I've shown you so far is essentially how you can create an idea that you have into a proper working web application with very few lines of Python code. All you require is A equal to 2, B equal to 5 kind of Python programming skills, because there was nothing complex, right? Some imports here and there. That is something that you can definitely learn. But once you have that amount of understanding of how to use Python, with a simple idea, you can create an entire ML-powered web application wherein you can train an entire classifier on your own data set with a pre-existing model and show it to the end recruiters as well, right? If you are in for the placement season, and if you show this particular demo that I've created something of this sort, and if you're able to explain concepts of deep learning to the end recruiter, I'm pretty sure you would end up getting the job as well. So this is something that I wanted to demonstrate with, again, an idea in mind that I want to classify images through a web application wherein I can upload an image, make a classification through ML. All I've done is I've used TensorFlow's multiple technologies, Python, some open source libraries to create this entire web application. If you want to host it free of cost, Then there is an organization called as Hugging Face, which gives you access to Hugging Face spaces, wherein you can basically host your entire web application free of cost. All you have to do is sign up on their website, and you can create an entire, say, web application to demo to potential recruiters that you have in mind, okay? So this is all that I had. I hope for people who were not from the ML background, you could take a lot from this session as well. Thank you so much for being such a patient and lovely audience. Thank you so much.
I hope that you will be able to use Gradio for your own portfolio. And for this talk, let's applaud for him and give him the memento. Yeah. So come and receive the memento, please.